Assalamu alaikum everyone. For our AAA 400 final year design project, under the supervision of Dr. KHOSRU M Salim sir, our project name is the Automated Road Dust Cleaner. I am Tashmul Islam Chaudhary with Ashraful Islam and Farazul Islam. So if we start off our presentation, we would look at the outline on the next slide. This is the outline. So if we move on to the background and motivation of our project, main motivation behind this project is that from a really early stage, we have seen that a country goes for manual labor to clean out roads and garbage from the roads and clean the roads on a daily basis, and using broomsticks renders fatigue. So it can be chosen as an inefficient work method. To overcome it, India has come up with a solution. If you look at the next slide, India has come up with a solution that they have made a huge vacuum machine which sucks out all garbage from the road and dust with an approximately of 3,000 liter. And the problem with the upside of this machine is that the contact of humans with the outside dust and garbage is very minimal. So if you look at the papers that we have done on literature review on the next slide, those three where we talked about the suction methods of scorching mechanism and the power consumptions of the trucks, which is quite huge. So while those problems that we've identified, if we go to the next slide, we can see that to overcome all those problems, our project, the objective of our proposed system is that we have to miniaturize this system into a miniaturized system. It has to be cost efficient. Our project has to reach out to 10 places. On top of that, it has to be eco-friendly. And to make sure that you understand what our proposed system is, I would like to call Ashraful Islam. Thank you.
Thank you, Tashimul. Assalamu alaikum everyone. I'm Ashraful Islam. So as you can see, this is our project's proposed system. The system on the left hand side was our initial concept of this project. On the right hand side, it is the final system of our project where we have used a battery, then the inverter and VFD, then an AC motor, then a propeller connected with a shaft with the motor. Then we made a mechanism with a PVC pipe which will help the suction process. Can I go to the next slide? To do this project, we faced some complex engineering issues. For the WP1, we used the knowledge gathered from the power electronics and drives, energy conversion, electrical circuits, power system, embedded system, and engineering drawing courses we have learned. For the WP2, we don't have any conflicting requirements. For the WP3, we have done analysis on the AC motor windings and the efficiency between AC and the DC motor, and gathered knowledge on the cord and the internal fans, holes, power head, brush, rollers, filters, metallic body, and vent. For the WP4, vacuum cleaners that are available on the market mostly run on DC or single-phase AC motor. Three-phase motors are not widely used. Also, there are some noise issues in our project we have faced because we are using a metallic body which makes a huge noise by the vibration made by the motor. So that's the issue we faced. And for the WP5, we have used the C compiler codes to run the microcontroller inside the VFD. And for the WP6, we can say that Dhaka City Corporation and other private companies can also invest in our project. And for the WP7, battery source, the controller, which is the VFD, and the vehicle that it will be attached with are very much dependent on each other, I can say. So I'd like to hand over the next part of the complex engineering to Farazul Islam, if we can continue. Thank you.
So thank you, Ashraful Islam, and my name is Farazul Islam. So I will continue the addressing complex engineering activities. So E1 range of resources. We had to make a large metallic housing to set up an induction motor and rewinding that motor to run our desired voltage and current with a metallic propeller and also some PVC pipes. And build this cleaner, also we had to use 4 12-volt batteries and an inverter VFD to control the whole system. And the level of interaction, To make this project, we need to interact with technician that how they rewinds and how they know and how they use it. So, and we relate them with our study, because before going to interact with them, we have studied about rewinding the motors. So after that, we in this interaction session, we have gathered so many new experiences and innovation, a new concept of using three-phase motor with low power consumption. And it also it is a innovation where DC motors are used in much more systems, but in this we are using three-phase motor to reduce the power. So consequences to the society or and in environment. Our project is much more eco-friendly, easy job for the laborers and more efficient than DC motors, easy installation and low maintenance cost. And the familiarity, in foreign countries there are bigger size of road dust cleaner existed, and but in our country we don't have much more manufacturer to build this type of large machine, that we can say no one does build like road dust cleaner in our country. And that's all my part, and I will hand over it to Ashraful Islam again to describe and demonstrate the design. Thank you.
Thank you, Faraz. So on the left hand side, you can see this was our initial 2D concept of the dust cleaner, where we have planned to make two separate compartments which will be used to collect the dust, and another part will be used to suck out all of the dust upwards. And on the right hand side, we have the final 2D concept of our project, where we have used a metallic body. Uh, Inside this body, we have used an AC motor, which is connected with a propeller with a shaft. We have used four 12-volt batteries and an inverter. So this is our 2D concept final, and this is our 2D design concept we have done in AutoCAD on the last semester.
So thank you, Ashraful Islam. I will talk about the PSIM simulation. Inverter design, we used a SPWM, which is sinusoidal pulse width modulation, in generally used to get AC output. But in this, we need SPWM and square wave combination in used for the inverter switching, because this new technique reducing losses by switching the frequency. To confirm the VFD process of the proposed design, it will take sample from input DC voltage by step down the 250 volt to 5 volt DC. After that, a higher frequency triangular wave 20 kHz is compared with a sampled sine wave by using comparator to build SPWM. As a result, the frequency of three-phase inverter will be varying with the output with the input voltage, and the generated square wave is also passed through a NOT gate that are shown in our simulation diagram, and which produces a signal out of phase with the original signal. The inverter is required for set of signals, so we used 6 IGBTs and to make an inverter circuit. Under this simulation, 3 set of SPWM signal and 3 set of NOT gate operated to perform the making the switch on and off. So in practical, they are both off for a short period of time called blanking time or dead time to avoiding short circuits. Those bridge leg are switched such that the output is shifted from one to another, and hence the change polarity occurs in waveform. So after that, we got the simulation result, as we can see here. This is our output result. So this is our small scale road dust cleaner that we have built in last semester, and after that we have built a large scale of road dust cleaner in IOB with the help of our supervisor Dr. KHOSRU M Salim sir. And here Ashraful Islam will describe the demonstration of our road dust cleaner.
Assalamu alaikum everyone, I'm Ashraful Islam. Here you can see we used a inverter and a VFD to convert the DC to AC and to control the frequency of the AC signal. We are using four 12-volt batteries to run this AC motor. This white chamber is the removable store where all the collected garbage and dust will be kept. Now you can see we are moving the cleaner towards the garbages and it is sucking them upwards. Inside this chamber, inside this metallic chamber, we have used an inverse L-shaped PVC pipe to send the garbages directly to the store on the back. You can see it's sucking all the garbages upwards. On the back you can see a very little amount of garbages are left on the floor because it's just a prototype. Now we'll be removing the store from the main body. You will see all the garbages will be inside this chamber, this white chamber. So you can see all the garbages which were in the floor now they are in the store. So that's how our project works, and this is the propeller we have used, and that's how this cleaner, the automated road dust cleaner, works.
Thank you, Ashraful Islam. So by taking the data manually, we generated the graph in Excel, and here we can see the soft starting of three-phase motor, and the motor took 33 seconds to go to the steady state due to soft starting. Here in the figure we can see initially at first 10 seconds the current remains 0. After that the current begins to increase from 27 seconds to 30 seconds, the current go to the peak. After that it decreases, and here the due to load effects. Talking on the load effects of the battery, initially the voltage was 49.5, but when the system runs at full load, the voltage dropped from 49.5 to 47.8. This drop is causing due to the load effect. The increasing temperature of the motor, here we can see although we supply low input voltage and high current, the temperature didn't increase as much as normal motor does. Here we can see the power consumption is dropping due to the battery voltage drop over time. Now I'll call Tashimul Islam to present. Thank you.
Thank you, Farazul. So there's less air pollution in overall if we look into that. And labels, it's more efficient if we look at it. It's more efficient than a DC motor. It's very easily installable and it has a low maintenance cost. It's eco-friendly. One of our major and most prior points that we have focused on from slide 1, because we have talked about sustainable and eco-friendly environment overall, because we want what's better for the environment, people, and everyone living in it. So if we look onto the next slide, we can see on the future scopes on how this project can be put into bigger and better ways. What we have got concerned and concise our project into is into taking dust and other particles which are heavy or semi-heavy. But what about those things which are much more heavier, like a peel of a banana, or even something like people, we as Asians, we most of us in Southeast Asia, we litter in our everyday life, and when we do that on the side of the roads, there's a when we litter, it's usually in large quantities, so it's quite heavy, and for a machine like this, it's going to be quite tough. So if we look at the future scopes, we can see that to suck out those heavy particles, it needs a better way or a mechanism to make sure that it can do something like that. So if we look into the 3D design for the future upgrade on the next slide, Farazul Islam, if you could change it. So this is what the 3D design for our future upgrade is going to look like. Thank you, Farazul Islam. So all in all, if we can conclude, we want to conclude that one of our greater mottos from semester 1 was Clean Bangladesh, Green Bangladesh, and it has been our primary motto. And if we look into the summary, we have always looked into the cost and time efficient. And during this time, COVID has put a huge impact on our project and everyday life. So, what better way to clean our roads with minimal human contact or any sort of contact and provide better health security than a system like ours, because you do not have any contact with anything. You can stay inside of an electric vehicle or any vehicle and let the automated road dust cleaner behind you take all the dust, so that it cannot, you don't need to manually operate it. In short term, it's just a miniaturized version of a big cleaner trucks that we find abroad. That's that. If we look into the next slide, that would be all. Those are our selected references, and thank you